So hello guys, this is Mohit Kumar. Today we are going to discuss about the question interval mod which is appeared in Codeforces from 1092 due to. So let us see what the problem asks. You are given an array consisting of n integers as well as a parameter k and an integer set n which contains two integers p and q. You can perform the following operation on a an arbitrary number of times, possibly 0. First, choose an interval L, R such that the length of the chosen subarray is at least k and an integer m which belongs to the set M. Then set AI to AI mod m for each I from L to R. You have to find the minimum possible value of sum of all AIs after all operations. And the input in the first test case contains four integers n, k, p, and q. The k value is nothing but the minimum size of the subarray that need to be chosen. N is the number of elements in the array. P and Q are the elements that are present in the set capital M. And we need to choose small m either from P or Q. Okay, let me explain this question with the help of an example. So we will be given n as some integer which ranges from 1 to 1e5. Let us take n as 7 in this case and k as 3 in this case, p as 3, q as 5. Now the array elements 8, 8, 8, 8, 10, 20, 15, and 6 and 7. Yeah, these are the elements in the array. So now let us see how to solve this problem with the help of this example. So first, what we need to do, we need to minimize the sum. We need to minimize sum of A. That is the array. Let's make this in this way. Okay, we need to minimize the sum of A after performing the operations. So what are the operations? Operations. First one, we need to choose a range L to R such that the chosen range is at least of length k. That is, choose L and R first and length should be greater than or equals to k. And then choose either P or Q and then make AI to AI mod P or Q. This is based on the element that we have chosen for M. Okay. After doing this operation, we need to minimize the sum. We can do, in the question they have mentioned that we can do any number of operations and also we can perform any number of operations on the same subarray any number of times as you can see here. You can perform the following operation on A an arbitrary number of times. That is as many times as we need. So if we can perform the operation as many times as we need, for every subarray, there exists at most three type of operations. Let me tell you what are they. Type 1 operation can be choosing M as P. Type 2 operation can be choosing M as Q. Type 3 operation can be choosing M as P first. Sorry, Q first and then P. You can ask me what about the remaining combinations of P and Q selecting? Let me tell you why they are not being considered here. What are the remaining cases? Choosing P multiple times, choosing Q multiple times, choosing Q, choosing P and then Q. So let me tell you why these three operations are not being counted in this three type of operations is why because if we choose P once, we already know that all the elements in the array will be less than P. Why? Because let me tell you with this example. If I take 10, 12, 13 and P as 3, after doing one operation, all the elements in this subarray will be turned into 1, 0 and 1. As you can see here, all the elements will be less than 3. If I do any type of operation or any number by choosing doing mod again, it will be less than 3 only. Like these elements won't be changed again and again. So doing p multiple times is not a good idea. And also the similar thing goes for q. And why not choosing p and then q? As in the question they have mentioned that explicitly that p is less than q. So we can say that doing mod with p at the first rather than doing with q will result in all the elements less than p. So if all the elements are less than p, in that case, we can also say that all the elements are less than q. So if I do mod with q with on those elements, there is no change or there is no effect on them. So let me tell you this case with an example too. Let us take the same example and p as 3 and q as 5. If I do first mod with p, then I get the array as 1, 0 and 1. So if I do mod with 5 for these elements, what I get? 1, 0 and 1 only. Why? Because all the elements are already less than 5. If I do mod any number of times or multiple number of times, that won't be affected. So at last I can say that these three type of operations are being ignored here. And also one more thing, I can perform either type 1 operation once or type 2 operation once or type 3 operation once. If I perform the same type of operation multiple times, it won't affect or it won't change the elements. So it is trivial to prove that while doing multiple times on the same subarray won't change the elements is why because after doing a particular operation on it, let's suppose 10, 12 and 13 only, if I do with if I choose m as 3 and I can take 10 modulo 3 here, 12 modulo 3 here, 13 modulo 3 here, you can see that we get all the values that are less than 3 and hence if I choose any value like, apart from 3 and some value which is q, I will always be getting the value that is already present at these positions. Why? Because all these values are already less than p or q. So I can say that can be only three type of operations that can be done for any type of subarray. Now let me tell you with this example how to solve the problem. So we are having this test case. So first let me choose this subarray. So after choosing this subarray, I can say that what about the remaining elements. You can ask me about what about the remaining elements, but first let me talk about the subarray that's been chosen here. On the subarray, I can either perform type 1 operation once, or type 2 operation once, or type 3 operation once, right? So if I perform type 1 operation, what's the or how the array will be transformed? If I perform type 1 operation choosing M as P, in the given question, we already know that P is 3 in the given example, I mean. So if I do type 1 operation, I get 8 as 2, and 8 as 2 again, and 10 as 1. And 20 will be remained as 20, 15, 6, and 7. They all will be remained as same. So this is what happens if I perform a type 1 operation on it. If I perform a type 2 operation on it, choosing Q as 5, I get 3, 3, and 0, and which is 20, 15, 6, and 7. So if I perform the last but not least type 3 operation, that is first by doing mod Q and then doing mod P. So first by doing mod Q is nothing but we are getting the subarray from the type 2 operation itself. Why? Because it's doing the same thing. So we are here with 330 and then 20, 15, 6 and 7. So again, if I perform the modulus with P, then I'll get to know what's the array that will be formed after type 3 operation. So if I do 3 modulo 3 is 0, 3 modulo 3 is again 0, 0 again. So this is the subarray that will be obtained after doing the type 3 operation. So in this way, three type of operations are being defined here. So now let us discuss what about the remaining elements. What about the remaining elements? In the question, if you see, we need to choose subarray of length at least k. But here we have already chosen subarray of length exactly k. So if I improve or if I increase the size of this current subarray chosen, what will the size of the subarray? If I increase the size by 1, it will be k plus 1. And in the question they have mentioned that we can take an array size of at least k. So k plus 1 subarray size is also valid. So we can just include the rightmost element or the element that's just after the subarray's end into the subarray, right? That is, if we are having the subarray this 8, 8, 10, I can include 20 in it, and the remaining all elements will be stayed still. So if you see the subarray size is 4, and in the question they have clearly mentioned that we have to take the subarray size of at least 3. We have taken 4, so that's not an issue. So when should I need to increase the subarray size? After performing either type 1, type 2 or type 3 operations, then I need to increase the subarray size. Why? If you ask me why, so before, let me tell you why. So after performing type 1 or type 2 or type 3 operations, we get to know that what's the minimum value or the minimum sum that all these three elements can be made to, right? We will get to know what's the minimum sum that can be obtained from the chosen subarrays elements. So here, after performing type 1. After type 1, what's the array? I'll write it here. 2 to 1. Now we are just talking about the subarray that's chosen and including 20 and including the next element only. After type 2, what's that? 330 and 20. 330 and 20. After type 3, it's 000 and 20. 000 and 20. Let me keep a space. Okay. After type 1, we can extend our window size to k plus 1. And after type 2 also, after expanding its size to k plus 1, and I have expanded the window size for all these three types. So if you carefully see, if I perform any type of operation on this window or on this element, it will be actually calculated as the minimum sum or the minimum operatable value for that value. So let me explain you with an example here. 20 can be made into 20 modulo 3 or 20 modulo 5 or 20 modulo 5, 20 modulo 5 modulo 3. So I can take the minimum among these. So you can ask me that we have chosen the array size of k plus 1. So we need to choose only a single m as our m in order to make mods to the elements. But first we have taken the size of k and then used a particular m to reduce the elements there. And now we are taking the size of k plus 1 and we are sure that all these three elements which we have chosen before are already less than p, which are at their minimum values. So this value is also greater than p or less than p. Let us not talk about that. This value is currently greater than p, right? So if this value is currently greater than p, I can make any of these operations in order to take the minimum operated value of that indexed value. So we can take minimum of 20 mod 3, 20 mod 5 or 20 mod 5 mod 3, which is in this case 0. Why? Because 20 mod 5 we are getting 0. So we can take this value as 0 here, 2, 2, 1 and 0. So you can ask me that you are taking an subarray of size k plus 1 and you need to choose exactly a single m, that is either p or q. You should not change p and q in middle, right? So first I have, see, if you can see, I have chosen 3 as m here, but I'm taking 5 as m here. But how can you say that in the question they have mentioned that you need to take only a single m for all the subarray, but I am taking here different m's. This will work. Why? Because at first I am taking the subarray of size k and use the same m, and now I am taking an extra element which is right after the subarray's end, and I am including it into the current subarray. So which leads to the size of k plus 1. And if you see that I am performing a modulo 5 on this, but even though I perform modulo 3 on these three elements, I am performing a modulo 5. Why? Because as all these three elements are already less than 5 and already less than 3, if I choose the subarray of size k plus 1 and then choose m as 5 again, if I do modulo 5, modulo 5, modulo 5, modulo 5 with all these four elements, it won't change, right? So it is just like, again, we are performing the operation on k plus 1 with choosing the m which is resulting in minimum of all these three values. I hope you understood this. So again, I will be taking the minimum of the above 3, which is 0 in that case. So 2, 2, 1 and 0, I'll be making this. So after performing a type 3 and choosing m as 5 for all 4 elements, I can say that it's 0, 0, 0, 0. So yeah, in this way, I can extend my subarray size to k plus 1, k plus 2, and k plus 3 in that way. In that way, I can extend the subarray size until n. And also, I can take the minimum possible value that can be obtained by doing modulo p, modulo q, or modulo q modulo p, that is all type 1, type 2, type 3 operations. So this will always result in the optimal solution. Why? Because we are trying to minimize the each and every element to its minimum value by taking the minimum of all these three operations. So which is actually the optimal value that can be obtained after performing the operations on any number. But we are restricted to choose a subarray of size at least k in the beginning. So what I did was, so first what I did was I have chosen a subarray of size exactly k and checked, sorry, so many typos here, and checked min values for remaining elements, and then I checked the same thing for every subarray. That is, in this case, we are confined only with the first subarray, but in reality, I was checking every subarray of the array of size k. Let me draw it here in order to get more clarity. So first I'm checking exactly this subarray, and I have computed all the independent scores for this. And then I was checking this subarray, leaving 8 and choosing the next three elements, which are 8, 10, and 20, 15, sorry, 15, 6, and 7. And then I am choosing this subarray, 8, 8, 10, 20, 15, 6, and 7. And then choosing the next subarray, which consists of 20, 15, and 6, 8, 8, 10, 20, 15, 6, and then 7. And then last, checking the last subarray, which is 8, 8, 10, 20, 15, 6, and so on. So in this way, I covered all the subarrays and every subarray. So if you see here, what I was doing, I'll explain in this step. So I was taking the minimum of type 1, type 2, or type 3 operations for the chosen subarray or the current subarray, and I'll calculate the minimum scores or the minimum transformed values for every other independently. That is by taking either minimum of modulo p or modulo q or modulo q modulo p. By taking minimum of all three type of operations, I am calculating this for every other element separately. So what I do is after choose or after calculating for the current subarray, I'll just simply extend this extend the subarray to k plus 1 size, and then the value that will be transformed at this position will be the calculated value of all the three type of operations, minimum calculated value of all the three type of operations. Why? Because as all these three elements will be less than p or less than q or less than the chosen ends, so this can also be either chosen with type 1 operation or type 2 operation or type 3 operation. So in that way, the solution works. So let me explain this idea with the code briefly. So you can understand very easily as the code seems a bit simpler and also a bit intuitive. So here is the code. First I'm taking the array as input, and I'm just initializing the sum with just the sum of the numbers there. And as I mentioned, the type 1 is modulo p, and type 2 is modulo q, and type 3 is modulo q modulo p. First, if you see, I am taking the window of size k and calculated it. That is this step. I was currently at this step, and I was taking the minimum of these three elements, type 1, type 2, and type 3, and I am keeping it into a variable or an array at the first place with minimum of type 1, type 2, type 3, minimum of type 1, type 2, type 3 for these three elements, and then I am continuing my window, that is just ignoring the 0th index element and taking the ith index. If you see, like, currently my window will be reaching here, so I take this element and I ignore the 8 which is at the last end. So in this way, I go to all the subarrays and I'll update the ARR array with minimum of type 1, type 2, type 3, and then I have taken prefix sum. Why? Why? Because if you see, what is the minimum cost that will be obtained? So what is the minimum sum that can be obtained after performing the operations is the score that is calculated for this and the individual scores for these remaining elements, that is this 8 and this 8 and this 6, this 6 and this 7, which is just simply the prefix of n, that is overall sum, minus the sum that is present in this region, right? I just need the sum of these two things and these two things. So in order to calculate the sum of these two things and these two things, I just need to calculate the overall sum, and I just subtract the overall sum from this sum. So I get the sum with this sum and this sum, and also I get the sum that is being covered by the current region. So that is what I was doing. So for every prefix of I, I'll be taking the minimum of nums of I mod p mod q and mod q mod p, which is type 1, type 2, type 3 operations. And then prefix of I is prefix of I minus 1 plus current, which is a standard way of writing the prefix sum. And I will be taking, as I mentioned here, if I am at this region, I need this sum plus the remaining element sum in order to calculate that. I was taking the region which is currently covered by the L and R, that is L and R, and I'll be taking their sum separately. See here, prefix of R minus prefix of L minus 1, which gives me the range, which gives me the sum that is covered by the current range, and prefix of N minus 1 will give me the overall sum. And what I do was, array of 5 will give me the sum that is calculated for that subarray only, and the current will give me the sum of the remaining elements that are not covered by that subarray. So if I print that answer, that is the answer. So this seems simple, right? As you can see, the problems are not that difficult if you try to change your perspective and view in order or while solving the problem. So as you can see, the output seems matching here. 111304569, 111304569. Let me try to submit this. But before submitting, let me tell you the time and space complexity for this code. The time complexity for this code is O of n for taking input and O of n for calculating the sums for each subarray, and O of n for a prefix, and O of n minus k strictly for taking the or for calculating the overall answer. So if I talk in terms of big O notation, the time complexity is O of n, which will easily pass for this solution. Why? Because and they have mentioned that it goes till 1e5 only, which is pretty good in limits. So the space complexity will be, if I include the integer array that we are taking the input to, it's O of n plus O of n for an array to store the values that are for each subarray. This is strictly O of n minus k actually, and also O of n for storing the prefix. So it is O of 3n minus k, which is not bad for 256 MB. It's very less when compared to 256 MB. So it's also within the limits. So the time and the space constraints are within the limits. So let me try to submit it to check whether it's working or not. It's taking a bit more time than expected. So yeah, running on this one. Hope it's accepted. Yeah, it's accepted. As you can see, it's accepted. Yeah, thanks for listening this.